Okay, let's go into 1.8, which is on exploring the mesh topology. This is a sort of a preparatory section for other things which use facilities here, and it helps you answer questions like how do I loop over mesh entities, what edges are connected to a vertex, or what about if I want to connect a list of edges connected to an element, or points of an element, elements adjacent to a face, all of these type of questions. You can answer them using the facilities in this tutorial. So we've graduated to the unit cube. Okay, so that's a three-dimensional domain. Okay, it is indeed the unit cube. Okay, here's how you iterate over vertices. Now, this V, which is an element in mesh.vertices, is an object, and when you ask that object to be printed, it just prints out this thing, V0, V1, V2, etc. And then if you then ask for the data attribute of V named point, then you get the coordinates at the point that represents the vertex. But V itself is something of this type, a type mesh node. It's a simple data structure which knows the number of that node, and we'll come back to that in a second. But let me, before I forget, talk about iterating over elements using this type of syntax: mesh.elements. And then you can provide either volume or boundary, and it'll pick up either boundary elements or volume elements and iterate over it. And you see the type of EL in this iterator. This is getting printed right here. It's something. It's an object of type NGS element, and the vertices of an element are being printed here. And the edges of an element, the edges of an element are being printed here. So here the element is a tetrahedra, so you can see 6 edges and 4 vertices per element. Okay, so these objects that we just saw inside these iterators, the node ID objects and the mesh node objects, a little bit more about them. A node ID can be created by passing into it any one of these types, and then a number representing its number in the mesh. It could be a vertex, edge, face, cell, element, or facet. While there are no cells in a two-dimensional domain. And if you want to get the this sort of mesh information, this is the syntax to use for associating this. You have a node number 20 somewhere in the mesh, but just knowing that number doesn't tell you much more about that vertex. So you have to associate that 20 inside a node ID and then associate it with the mesh, and then you can query points like the coordinates of the point and things like that. Without the mesh information, the node object is just a number. Okay, so the type of V, the argument to this mesh, this is something of type node ID, whereas the result after you apply the mesh to it, you get something called a mesh node. So these are the two objects. Mesh node has mesh-based information, and node ID just has a number. Okay, now if you ask mesh V to return all the edges connected to that vertex, well, it gives you all the edges by asking for edges. And similarly, you can now do a cell, create a node ID. So this corresponds to cell number 1 in a mesh, and you make the mesh node object, and then you can ask what are the faces of this particular element, and now similar things. We're in a 3D mesh, so you have faces, and so you can make a face object associated to a mesh and then ask its edges and elements and so on. Okay, and we saw that we could pass in volume or boundary to these element ID objects, and that's also useful in order to query for topology information. For example, the type of the mesh. So again, once you associate an element ID with a mesh, you've gotten yourself an NGS element object, which knows information about the global numbers of the vertices associated to it and so on. Okay, so there's more. You can come back to this page and look at all the facilities, because when you're iterating over mesh entities, sometimes you say, okay, how do I do this? And I go back to this tutorial and say, okay, this is because I don't remember this. So this information is there, and when it's put in the tutorial, then it's a promise by the developers that it will not change anytime soon.
Maybe you asked what is the difference of the cell and the element.
Yeah.
It's for the volume, it's not a big difference, but an element, it can be a boundary element, so we enumerate the surface elements.
Yeah.
But there's a different idea to the faces, but the faces are all faces in the mesh.
Good point. Okay, one more thing before we quit this discussion about enumerating quantities of the mesh, which is degrees of freedom. This requires more than a mesh, because this degrees of freedom corresponds to a finite element space. So if we have a mesh and we have a finite element space, then we can iterate over degrees of freedom. For example, here is a Lagrange finite element space on this mesh, and you're looping over all edges in the mesh edges, and you're asking the finite element space, what are the degrees of freedom associated to an edge? So this is a finite element space of order 4. A degree 4 polynomial on an edge is determined completely on that edge by 5 points. So if I remove on that edge, if I remove the 2 vertices, the edge degrees of freedom, that we should see 3 degrees of freedom, and you're seeing 3 degrees of freedom. And the numbers of those degrees of freedom for every edge. You could do the same thing. What are the degrees of freedom associated to an element instead of an edge? So here is loop over elements over all volume elements, and then we're asking what are the degrees of freedom associated to that element, and out comes a list of many degrees of freedom because it's a degree 4 element. Okay, any questions? There's also the help feature, which is useful. You can, instead of asking me questions, you can ask help questions. No questions. Okay.